As software engineers, programmers, coders, whatever have you, we are hired to solve problems using code. Now, the code that we write is eventually turned into an object file, which is a representation that contains machine code as well as application metadata. That object file is then turned into a binary executable that would eventually be run by your operating system, and that would turn into a special thing called a process. Various types of process exist, and in today's video we're going to have a look at a special kind of process called a daemon and how we can turn a normal process into a daemon. So if you want to find out more, stay tuned. Well, earlier I said that different type of processes exist. We're going to discuss some of the very basic type of processes, and we're going to talk about 3 of them. The first one that is most known is the foreground process. And the foreground process is usually tied or bound to a terminal, right? And then we have another one called the background process, and this is usually run asynchronously. In a shell. And then we have the one that we're going to focus on in this video, which is the daemon. And the daemon is differentiated because it is not bound by a terminal. So that means everything like standard input, standard output, and standard error are not channeled to a terminal. It's not bound to a terminal. So now that we have this understanding, let's actually see how we can turn an application that then transforms into a process into a daemon. Now that we have the information about the daemon, that it is never bound to a terminal, now we can move on to the next step and actually understand the steps that we need to follow to turn a process into a daemon. And let's have a look at that. To do that, or to turn a foreground process into a daemon, we need to follow 3 essential steps. The first is to fork the process. So the reason we do this is we want the parent to exit, the parent process to exit. We now have a child process, and that child process is not going to be the process group leader. The second step that we want to follow is to call set SID. And this function essentially allows us to create a new session. And this new session would now be the session leader, and it won't be attached to a terminal. And now what we want to do after that is to redirect the standard file descriptors. So when we speak about standard file descriptors, we are talking essentially about standard output, standard input, and standard error. And these are the standard file descriptors that are always attached to a terminal. And the reason we do this is to ensure that the process or the daemon never accidentally reads or writes to a terminal. And following these steps, we can ensure that we can transform a normal process into a daemon that is never bound to a terminal. Cool. So now that we know these steps, let's actually see how we can turn a real application into a daemon. So I have my terminal right here, and I'm writing this server application, and I've added the capability for it to be run as a daemon. So if you see, we have some C code here, and we have some logic that tells us that if the server if it has the property of daemonize set to true, then we daemonize the application. Otherwise, we don't daemonize the application and we'll be bound to a terminal. So now, how is that actually done? Well, if we look at the daemonize function here, we can have a look at how this is actually done. So here we have a daemonize function. In line 33, we actually declare a variable of type integer that essentially is going to be used to store the file descriptor. And then here on line 35, we call the fork function. And if it does not return a 0, then that means we have essentially fork the process, and we can exit the parent process. And then we move on. If we are now in the child process and we've exited the parent process, then everything that's going to be run here, we run as part of the child process. And what happens next? We have this condition that says that if set SID is equal to -1, meaning if something fails, if we fail to set the child process, create a new session for the child process, then we're going to essentially print error starting new session to standard error to the terminal, essentially, and then we're going to exit the application. But if everything works out, if we are able to create a new session, then what we do is essentially call open on the dev null, which is essentially a virtual device. It essentially works as a mechanism to essentially throw all standard input, standard error, standard output into what essentially is a black hole, so that it does not get written anyway. So what we want to do is redirect the standard file descriptors to this virtual device, which is essentially a black hole where everything goes into this to this null device and it's never used. So that way we ensure that that data is never written to the terminal. We can never read from the terminal. And that's essentially the steps that we need to follow to ensure that the process actually gets daemonized. And let's have a look quickly at this application. So I'm going to look at the configuration that I have for this server here. I am going to open the configuration. So right now, daemonize is set to false. So that means that when we run the server, it will not be run as a daemon. So let's run cmake. Let's build this project. And then let's run it. And let's pass in the config file. Okay, so we've run the server application. We've initiated the server. The server started on a port 55995. Here we have a current process number and the time that we started the server. And this is all being directed to standard output, right? Because this current process is not a daemon and therefore it's bound to a terminal. Now let's see what happens if we set daemonize to true. Let's close this, right? So we don't see it running here any longer. If I run this, you would see it running right over here. So let me close this again. We see that the process has disappeared from the process list. And let's go back to the terminal and let's set daemonize to true. Let's save this and let's run the application again. So if you see, the application has been run by the operating system, and it's now turned into a process. We see the process ID over here, but we don't see anything in the terminal. And that's because the application or the process has been daemonized, meaning it's no longer bound to a terminal. So this is a simple way for you to daemonize a application written in C so that it's no longer bound to a terminal. And this is really useful for servers, for cron jobs, and for many other types of services that need to be run as daemons. Things like SSHD, HTTPD by Apache, and many other applications. So in today's session, the goal was to essentially learn how we can daemonize a project or a process so that it gets turned from a normal or foreground process into a daemon. Awesome. So that's how we turn a normal process or foreground process into a daemon using the C programming language. If you enjoyed the video, please leave a comment down below and subscribe. Until next time.